Solving multi-step equations with distribution. We used the distributive property already, so just as a review, remember the number on the outside of the parentheses, if it's directly next to the parentheses, we multiply by everything inside, being very careful with our signs. So for this, we have 5x plus 10. Over here, again, we're very careful with the signs. Negative 2 times 6. And then negative 2 times negative x is a positive 2x. So that's just using the distributive property. Then we get to two-step equations. Again, we're doing inverse operations, so reverse order of operations. And we're solving. Number 2, a little harder. Be careful. Look to the right. It says leave the term with the variable alone until the last step. So again, we want to worry about the constant term, or just the number first. Notice we have a positive 7 here, so we will subtract 7. We're very careful to bring down the negative x. Notice x is not alone. That says negative 1 times x. So we will divide by negative 1 on both sides, and we get x equals 17. So what this section is all about is combining those two ideas of the distributive property and then multiple step equations. So if you can do those, you can do this. So if we have an example like number 1, we want to distribute first. We want to get rid of those parentheses. So we will distribute the 5. And now we're back to just a two-step equation. So all we did was distribute, and now we're back to the last section stuff. Add 35 on both sides. And divide by 5 on both sides. Again, I am not always going to show the check, but that's important to do just to make sure you're right. You can guarantee the right answer by plugging the 25 back in for x. Very important to do that. Number 2, same idea. Distribute, careful of signs, and solve like normal. The third one, same thing. Do not let the fraction scare you. A fraction is just the number, just like any integer. We'll distribute 1/2 times x, 1/2 times 6. We will subtract 3 on both sides. And two different ways we can say this. We can say we divide both sides by 1/2. Or you could say multiply by the reciprocal, which would just be multiplying by 2. Either way is correct. Okay, we will have two different x terms here. Order of operations says to do the parentheses first. Now in parentheses, we can't do anything there, right? You can't combine x minus 2. They're not like terms. But we do have, we're subtracting here, and then we're also multiplying here. So we're going to do the multiplying first, because order of operations tells us so. So you can see over here it says about distribute the negative 3 first. So I'm going to bring down the 4x, and now I'm going to distribute. Negative 3, watch your sign, times x is negative 3x. Negative 3 times negative 2 is a positive 6. Make sure that negative stays with the 3, as in negative 3. Now we're combining like terms. So our x values, we have 4x minus 3x, which is just 1x. The plus 6 comes down. And we subtract 6 on both sides to get x equals 15. Could definitely check that and plug 15 in. You'll have to plug it in 2 different spots, but it will equal 21. It will equal a true statement, so you know you're right. Same idea with 5. Distribute first. So negative 2 times 4, negative 2 times negative x, and then bring down the minus 5. Our like terms here are the negative 8 and the negative 5. So when we combine those, we get negative 13. We will add 13 on both sides because it's currently being subtracted. And we'll divide by 2. So x is 12. Okay, there are 5 practice problems below this. I would like you to pause the video. I will write the answers up here, and then you can check your work to that. So please pause the video now, and then we'll continue with notes after you check. Okay, the next part of this section, solving equations with variables on both sides of the equal sign. So it won't just be on one side. We won't just simply combine like terms, but it's on opposite sides. We will treat that the same way we treat numbers on opposite sides, that we are just going to do inverse operations to move the x's back and forth from one side to the other. So if you look at the first example here, we have 4x plus 5 equals x minus 4. We need to get the x's on the same side. You can do different things. You can either choose to get this x over here, or if you don't want to do that, you can get this x over here. It does not matter. I will look and do what this says here. And it says we need to get the x over with the 4x, so we will subtract it from both sides. So we're going to get this x over here, just because that's what the words say here. So notice that x is currently a positive x. That's currently being added. So inverse operation, we will subtract x on both sides. 4x minus a 1x is 3x. And we're back to the other section where it's just a 2-step equation. We're going to subtract 5 from both sides. We're going to divide by 3. And we get x equals negative 3. Example number 2. We have 3x minus 5 equals 5x plus 7. So again, we want the x's on the same side of the equal sign. You choose which x you want to move. Personally, I try to move the smaller x so you still end up with a positive number for x. So I would choose to move this over here. But again, you could do this over here. It does not matter. So I'm going to take the 3x, which is currently a positive, and I'm going to subtract that on both sides. And I get negative 5 equals 2x plus 7. I'm going to subtract 7 on both sides. And I'm dividing by 2. And I get x equals negative 6. Can always plug that back in for x and see if it works. The third example. Notice I have y's at 3 different spots. 2 of my y terms in yellow are on the left side of the equal sign. They're on the same side. So what we're going to do with them is just combine like terms like we did in the other section. We're just going to be very careful of our signs. So we have a 7y minus 3y. 7y minus 3y is 4y. The other like terms we have on the left side are the positive 5 and the positive 1, which equals 6. So we cleaned up the left side. I just brought the right side down. I'm not trying to do too much in one step. Now I'm back to a problem like we did earlier in the notes where we just have variables on both sides. I'm going to get the 2y over to the left-hand side. I'm going to subtract it because it's currently positive. And now I'm just solving like I would any other time. And I get my answer of y equals -2. Okay, one more problem, one more example I want to show you here because something weird is going to happen with this one. So let's see what it is. Looks like a pretty basic problem. We have x's. Let's worry about the right side first. Let's clean that up. So 4x minus 7 equals 6x minus 2x is 4x plus 5. Okay, the x's are the same, you'll see, so I'm just going to choose to move it from right to left. Subtract it, it's currently positive. Careful here, algebra. 4x minus 4x is 0, right? It's nothing. It goes away. If I have 4 apples and I take 4 apples away, I don't have an apple. I have nothing. I'm going to bring down my -7. I'm very careful to bring down that negative. Again, those 4x's cancel, and I'm left with 5. This statement says -7 equals 5. Is that a true statement? That is obviously not a true statement. If you get to a point where your variables get eliminated, where you don't have x's or y's or anything else, you just have 2 numbers that equal each other. If it is a false statement, your final answer that you need to write is no solution. And what this means is no matter what number you plug in for x, the statement will never be true. There is no number for x that will make this equal. You could keep going here if you wanted to, and, for example, add 7 on both sides. But notice you still get a statement 0 equals 12. That's not true. That's no solution. You want to remember this phrase. If you get a false statement, it's no solution. I don't have an example of it here, but if you would get your variables to completely cross out, and you would end with an answer like 2 equals 2, which is obviously a true statement, your answer, we would say, is all real numbers. Or sometimes you would see infinitely many solutions. That's important to know. So you could have 3 different answers with these problems. You could either have x equaling a number, whatever number. You could have no solution for a false statement, or you could have all real numbers for a true statement. Please be familiar with all three of those. There are 2 practice problems below that I would like you to try as well. So I'd ask you to please pause the video now and then check your answers.